So this question is add two numbers too. So you are given the two linked lists, and then you want to return when they add together. So if you notice that this linked list is kind of odd, right? Because this is the last value, and this is the what? The most significant, value. So imagine this 700. Like it's supposed to be starting from 0, right? But they are not. They're starting from the head. So I mean that's fine. And let's just keep looking. So this will be the 7, right? This will be 10, and this will be 7 plus 1 8, and then 7. And then you want to return this guy, the head, and then this will be it, right? So one of the solutions is actually pretty tricky. So we actually reverse everything. We reverse everything, and then we add, 3 plus 4 is 7, we create a null, and then we point at the next, the next value. 6 plus 4 10, so we create 0, and then we put one carry over here, and then 8 7, and then we're just doing this, right? So once we have this one, so it's going to be 7087. So our head is here, but you want to return 7807, right? So we need to reverse this linked list as as a beginning, so it's going to be the same idea. So let's just look at this. So if you are not familiar with the reverse, you can go back to one of the video to talk about how you reverse the linked list. So I'm gonna call reverse this no. So what you need is actually pretty straightforward. You need a pre say equal to no. So while no does not equal to no, you want to find out your next equal to no.next, and then you want to say your no.next equal to pre. So you change the direction, and then you want to set your pre equal to the current, and then traverse your no equal to next. So you'll keep going on the next one, and then when you return, the pre will be the last value. So if you're still not familiar with list reverse algorithm, you need to go back to watch one of the video about it. So I need to do what? So L1 will be reverse L1, L2 will be reverse L2. So I don't need to allocate a new memory for new linked list. So I'm using the same linked list, right? So now this is pretty straightforward. I need to use adding, so it's going to be using the what? The add to number 1 probably. So what you need to do is what? You need to return add L1 L2, I believe. And then what you need to return is return linked list, list node, add list node. I'm gonna call A, list node B. So what you need is what? You need a carry value. This is pretty straightforward. Dummy new list node, and also I need to create another one in which it will traverse current equal to what? Dummy. And then what you need to return is what? It's actually a reverse dummy.next. I will talk about this later, but let's do it later. So while A is not equal to no, B is not equal to no, I will just keep traversing. So in x equal to what? If A equal to no, right? I will just say 0. Else it's going to be what? A.val, right? And y will be exactly the same thing for b equal to no, 0 b.val, and also the summation is going to be x plus y plus the carry. So carry will become sum divided by 10, right? So now you know, like you have a the value for the current list node. So I'm creating a list node. I'm going to call node equal to new list node. The value is going to be sum multiplied by 10. So my current.next point at the node, and I'll move my current.next, right? So I need to traverse my A. So if A equal to no, I will say equal to no. Else it's going to be A.next. So it's going to be exactly the same thing for B equal to no and B.next, right? So you will just keep traversing until the end. You want to check, does my carry is not equal to 0. You want to add a new one, so it's going to be current.next equal to new list node, and the value for the carry is definitely 1, and it's not going to happen 2. Right, so it has to be 1. So you need to reverse at the end is because you're doing from here 7 0 8 7, so the direction is going left, right? So your output becomes 7 7 0 8 7. So it's a opposite direction. So you need to reverse. So you become 7 8 0 7. So this is pretty much a trick. Submit. Alright, so let's talk about time and space. This is what? All of L1. This is all of L2. You reverse, right? And what happened to here? So this will determine the A or B, right? A is represent L1, B represent L2. So it's going to be, so when does it break? You will break until both of them are null, right? So you want to find out the time complexity for this one. It's going to be the maximum between the A or B, I mean the length of A or B, right? So it's maximum between these two linked lists. And the space is going to be the same. It's going to be maximum between A or B. So it has to be a maximum. So this will be the time. The space is going to be what? Pretty much constant. You're not allocate any space. So this will be a linked list solution. So let's look at this. What happens if you're using a stack to solve this question? So if you have stack, I'm going to say stack 1, stack 2. You have 7, so 7 2 4 3, and you have what? 5 6 4, something like this, right? So yeah, I just add into the stack, and then this value is definitely, you know, we have the same position, same lineup, same alignment, right? So 3 has to be what? Add with 4. 4 has to add with 6, and you have carry, and 2 have to add with 5, and then 7, something like this, right? So once you have it, then you still need to reverse because you're doing everything reversely, right? You need to revert the leftmost bit 7, and then 8, and then 0 and 7. If you add this one and then you create a node for this value, it's going to be 10. So you have 1 increasing, and 5 plus 2 plus 1 8, and then this will be your output for the stack solution. I mean, if you want to reverse, so you still need a reverse helper function for the stack. So let's work on the reverse first. List node, reverse, list node, no, list node, pre equal to no, while no is not equal to no. You want to make sure you have next equal to no.next. So no.next is actually reset to pre. Pre will reset to should be no, right? Pre reset to the current position, and no equal to next. So you move on to the next one. So you want to return the pre, right? So this will be straightforward. So you want to create a stack. Stack is going to store the integer only. You're not going to store the list node. You only store 3 4 2 7, and then I'm going to call what? I'm going to call this one. Okay, I'm going to call this one. This one equal to new stack. List 2 equal to new stack, and then basically I just traverse. So while this one is not equal to no, this one that L1.val, L1 equal to L1.next. So happen for the L2 as well. Alright, so using the same idea, we want to traverse until this is empty, right? So while this one is not empty, or list 2 is not empty. So I'm going to still create an A or B, right? A or B because if this one that is empty, initialize to 0, else no, I pop. So B will become this. Wait, this is this one. This 2 that is empty, I will initialize to 0, else this 2 dot pop. I need to say sum equal to A plus B plus carry, and I forgot to initialize my carry equal to 0. And also I need to create a dummy node. So current equal to dummy, right? So now I need to say carry equal to sum divided by 10. So the logic is going to be the same, right? So current create a list node. List node equal to new list node sum multiply by 10, and I need to say current.next equal to node current equal to current.next, and reinitialize my what? The next value, right? Should I? Oh, I shouldn't, because it pop every single time, right? So okay, this will be it, right? So I point at my new node, I move on to the next pointer, which is going to be empty right now, and I will reinitialize it, right? I will reinitialize this on the next iteration. So if the carry is not equal to 0, you need to say current.next equal to new list node L1. Alright, so everything is perfectly fine, and then what you need to return is what? The reversal for dummy.next, right? So this is going to be the same idea, and then it's not going to hurt. Just understand the logic, and this will be fine. So let's look at the time and space complexity. This is a space. This is also a space. So this is important. Space is going to be the maximum between L1 and L2. You traverse and add, right? So it's going to be maximum L1, L2. Depends which one is bigger. And this one definitely traverses everything. It's still maximum between L1 and L2. So this will be the solution. So if you have any question, leave a comment. And yeah, did I not talk about the time and space for this one? This is time maximum between A, B, and then this is time, right? Space is constant, right? You not allocate any space. And yeah, if you can look at this one and this one, this is with a stack, you have more memory. This one is traversing only, no stack. So this will be the final solution. So if you have questions, leave a comment, and I will see you next time. Bye.